So to begin the process of making the conversions by the 5-step method that we've outlined, first of all, I'd like a pen. Now, we start by reading the question carefully and writing everything with numbers, units, and label. When I read that a mixture is 35% by mass sugar, I write down we have 35.0 mass units of sugar for every 100 mass units of the mixture. But since I know the other thing in the mixture, there are two other implied ratios. One is the other 65 mass units have to be the other substance, salt. And so there must be 65 mass units of salt for every 100 mass units of this mix as well. And I can also, it might help in some problems, write the part to other part ratio. There must be 35 mass units of sugar for every 65 mass units of salt. Number, units, label. I then go on to read that sugar is 40% by mass carbon. Now that means I have another ratio, 40 mass units of carbon for every 100 mass units of sugar. Now, this is the only ratio I have for this percentage because I don't know what the other parts of sugar are. I only know that part is carbon of the whole sugar. I don't know what the other parts are to whole, and therefore I don't know the part to other part ratio either. So far, this is all the data I know. Then, in part B, which we're on right now, I'm also given 5 kilograms of mix. So, step 1, number, units, label, number, units, label, number, units, label, number, units, label, number, units, label. Step 2 is identify what quantity we're trying to find, and the question clearly says we want a mass of carbon. Well, even though these are all mass units, I don't see carbon as a label anywhere. And here I do see mass units of carbon, so this is the answer I should start with. And I'm going to rewrite it to begin with 40. Now I need to pick mass units. I need to commit to some sort of units of mass. And since I see kilograms used later in the problem, it might save me time by writing 40 kilograms of carbon for every 100 kilograms of mix, or excuse me, sugar. Now, that essentially is the answer I want, a mass of carbon. However, a quantity I want to cancel is this, mass of sugar. And the only thing that can cancel a mass of sugar is a mass of sugar. So I go looking for a mass of sugar. It's found in the numerator of this ratio, and it's also found in the numerator of this ratio. Now you may be deciding, how do I choose which one to cancel this mass of sugar with? Well, the smart choice would be to evaluate what you're going to do if you use this one. And if I use this mass of sugar up here to cancel a mass of sugar, I'm going to replace a mass of mixture in the denominator. And that will have to be canceled also, just like I'm trying to cancel mass of sugar. So I look ahead and go, well, I've got a mass of mix, so I could cancel a mass of mix. So this is probably the mass I want to use to cancel my mass of sugar. If I look at the other choice, mass of sugar up here, mass of salt would go down here. And I'd have to cancel a mass of salt. And I could do that with this right here. But that introduces a mass of mix, which I could then cancel with a mass of mix. But by using this ratio, I'm adding a step. It can be done more quickly by using this ratio. There are 35.0 kilograms of sugar for every 100 kilograms of the mix. Kilograms of sugar cancel, replaced by mass of mix. And since my mass of mix is in the same units, I can just go right ahead and cancel the mass of mix with the mass of mix, leaving me a mass of carbon. Step 4 is complete, canceling what I don't want. Step 5 is always check and see if you're asked for specific units. And since it simply says what mass of carbon and not what units, these are absolutely good units for a mass of carbon, kilograms. So I divide 40 by 100, I multiply by 35, divide by 100, multiply by 5, And I recognize that I would like 3 digits in my final answer, and that answer is 0.700 kilograms of carbon. Now let's apply the same reasoning to the next problem farther on down, because it's also using this same mixture. The only difference is I no longer have 5 kilograms of mix. Instead, I'm given this piece of data, 226 grams of carbon. And here, with number units label, number units label, number units label, I'm asked what mass of salt is in the mixture. Well, the only place I see a mass of salt, well, I see it in 2 places actually. Here is a mass of salt, and here is a mass of salt. Now, if I start with this mass of salt, I will need to cancel a mass of sugar, which I can do because mass of sugar exists right here, but that will leave me with a mass of carbon. And of course, if I cancel the mass of carbon, I can do that with this mass of carbon I was given right here. So I'm thinking this is probably the mass of salt to start with. On the other hand, if I start with this mass of salt, I have to cancel a mass of mixture, which I could do with this mass of mixture. But that would leave me with a mass of sugar. And if I wanted to cancel that, I would probably have to use that mass of sugar. And then I would have to cancel the mass of carbon with mass of carbon. Now that sounded identical, but in fact there's one more step doing it this way. So I'm going to start with this mass of salt. I want it in the numerator, so I have to rewrite the ratio as 65.0, and some convenient mass units in this problem would be grams. Grams of salt, are equivalent to 35.0 grams of sugar. So there's essentially what I'm being asked for, a mass of salt. It leads me to now have to cancel a mass of sugar. And this mass of sugar here, if I invert the ratio, can go ahead and cancel that mass of sugar. So I think I'll do that. I'll say that 100 grams of sugar are equivalent to 40 grams of carbon. And I have canceled mass of sugar, but I have substituted a new quantity, mass of carbon. But that's not a problem at all because I'm given a mass of carbon in this part of the problem. And by multiplying by that mass of carbon, I cancel mass of carbon, leaving me at the end of step 4 with my mass of salt. Step 5 is to see if any specific units were requested for that mass of salt. But when I reread the problem, it doesn't specify. So let's not tempt fate. Let's leave it as grams of salt. So I would grab my calculator and divide 65 by 35. I would multiply by 100, divide by 40, and multiply by 226, leaving me an answer with 3333 digits. And that answer would be 1.05 times 10 to the third grams of salt. Now, let's check out the second problem then. Because if we follow the same procedure, we should have the same final result, a correct answer. This reads an aqueous solution, so aqueous means water as a solvent, of salt. So we have salt and water. The solution is the whole. Salt's one part, water's the other part, solution is the whole. Is 22% by mass salt. So I immediately write 22 mass units salt part for 100 mass units whole solution. I can then also write 78.0 mass units of the other part, water, to 100 mass units of the whole solution. And I can also write 78 mass units of the other part are equivalent to 22 mass units of the first part, salt. And then I continue to read, and I read that salt is 60.9% by mass chlorine. So I have another ratio, 60.9 mass units of chlorine per 100 mass units of salt. Now, since I'm not told what the other part of chlorine is, This is the only ratio I can write at this time. We continue to read that we're given a density, and it's the density of the solution. So I would write 1.255 grams of solution over 1 centimeter cubed of solution. Number, units, label for everything. And then I'm also told that we have 2 gallons of the solution. Gallons. Solution. And I'm going to have to do the problem down here. I'm running out of space, but I will start by asking what quantity I'm looking for. And clearly it asked me for a mass of chlorine. This is the only mass of chlorine I have, so I know where to start. 60.9, and convenient units in this problem look like grams for mass units. Grams of chlorine per 100 grams of salt. There's my answer. However, I need to cancel this mass of salt, and the only thing I know that cancels a mass of salt is a mass of salt. I'm given a mass of salt here in ratio with mass of solution, and a mass of salt here in ratio with mass of water. Well, if I use this ratio, I'm going to have to cancel mass of water, and it looks like that's going to add a step. But if I use this right here to cancel mass of salt, I will introduce mass of solution, but then I can go ahead and cancel it with this mass of solution, which will leave me with a volume of solution. But then I can cancel the volume of solution with volume of solution. So I'm looking ahead and trying to see that one number that's not a ratio. That's what I got to get to, because that's the thing that's going to ultimately cancel once and for all what's in the denominator. And this is a volume of solution, so this is the ratio I'll use to cancel my mass of salt, namely 22.0 grams of salt are equivalent to 100 grams of solution. Cancel the salt, replace it with solution, but now I can use this mass of solution to cancel the mass of solution. 1.255 grams solution is equal to 1 centimeter cubed of solution. Mass of solution cancels, and I have a volume of solution to cancel. No problem. If I can convert cubic centimeters to gallons, I can use this to make my final cancellation. 1 centimeter cubed of anything equals a milliliter of that thing. And of course, 1 milliliter is 1,000th of a liter. And 3.785 metric liters equal a gallon. So now all I have to do is cancel gallons. And that can be easily accomplished using the 2 gallons. I would have to do it down here or just kind of squeeze it in here. 2.00 gallons solution cancels from up here and down there. I grab my calculator and divide 60.9 by 100, multiply by 22, divide by 100, multiply by 1.255, divide by 10 to the negative 3, multiply by 3.785, and multiply by 2.00. This is a 3-digit measured number, 3-digit measured number, 4-digit measured number, 4-digit measured number, and a 3-digit. So I want a 3-digit answer. My calculator reads those 3 digits as 1.27 times 10 to the third, and the units would be grams of chlorine. And of course, I didn't need step 5 because it didn't specify units that I needed. Now go ahead and follow the same procedure on this last part of the problem. And of course, you no longer have this piece of data. You'd instead have 1.5 kilograms of chlorine. And of course, here you'd start with a volume of solution. So you're going to begin with that quantity right there by inverting it. And if you do the problem correctly and calculate the final answer, you should get 8.92 liters of the solution.